A robot is really just a special kind of machine, a machine that thinks and moves totally on its own. Give it a job and it just does it. No help needed. It's kind of wild to think about. But long before the tech we have now, people were already dreaming of these metal helpers. They just desperately wanted machines to do all the heavy, hard work for them. So they started small, building these really intricate little toys with springs and gears. And those were the very early, tiny steps toward the machines we rely on today.
But the actual word robot, it means forced labor. A writer named Karl Čapek made it up for a play about artificial workers. It's a pretty intense, almost spooky concept, right? And it definitely both scared and totally excited people back then. Before real robots even existed, early inventors made these beautiful clockwork dolls that could write letters or even play a little music. But they weren't making actual choices. They were just trapped on this strict preset path of gears. To make a real robot, well, gears just aren't smart enough to pull that off. A true robot needs a brain. Scientists had to figure out a way to give machines complex instructions, which led to using computers to function as those brains. And these computer brains? They're made of incredibly tiny switches that turn on and off so unbelievably fast. That crazy fast switching is exactly what lets the machine track things, make choices, and actually act smart in the moment. But a brain just floating in the dark is pretty useless. A robot has to actually know what's going on around it. It needs to perceive the room and feel the ground. So scientists built sensors to help them spot solid walls or detect unexpected bumps along the way. That way, they aren't just guessing in the dark. The way this works is actually pretty slick. Let's say a touch sensor feels a bump. That sensor instantly fires a message straight up to the brain. The brain then reads that message and decides what to do next, based on a set of rules. We call that a program. A human writes these rules beforehand. So, if the rule says, if you feel a bump, stop, the robot just stops completely. It follows our rules perfectly. Now, to physically act on those decisions, the robot obviously needs power. Instead of flesh and bone, it uses motors to spin its wheels or lift its heavy arms, all while the brain tells those motors exactly when to move. And for the energy to run those motors, well, it's just like how we eat food to get energy. Robots use heavy internal batteries packed with electricity to power through their day. The very early true robots to hit the scene bore absolutely no physical resemblance to us. They worked in massive factories, basically taking the form of giant, tireless metal arms. They were incredibly strong, easily lifting huge metal sheets day and night without ever getting tired or bored. But they weren't very smart. They were just trapped inside these heavy safety cages, swinging blindly to their spots, repeating the exact same job over and over and over again. Because they were swinging blind, they totally freaked out if anything changed. If a car part was just an inch off, that giant arm would smash right into it, causing a huge crash. Teaching robots to step out of those cages and handle the shadowy, unpredictable surprises of the real world became this massive, looming challenge for scientists. The real world is just wonderfully messy and full of trickery. Think flat floors hiding sudden bumps, and shadows appearing as solid walls. Which brings us to a really fascinating question. Why is walking such a giant math problem for a machine? I mean, a wobbly toddler can pull it off, right? But for an early machine, walking meant perfectly calculating gravity and motion in real time. When they tried, these walking machines just fell over heavily. Gravity pulled them down way too fast, and their computer brains were just too slow to crunch the numbers and catch themselves before hitting the ground. So engineers got stuck in this really frustrating trap. To calculate balance fast, they needed faster brains. But fast brains require a massive amount of power. So engineers had to load them up with heavy batteries, which just weighed the robots down. And of course, all that extra weight just made them fall over even harder. It was a whole mess. To figure this out, scientists built tiny tilt sensors. These clever little digital sensors instantly spot when the robot leans and warn the brain to push the ankle motor, keeping the whole machine standing upright. Before this, engineers actually looked to nature, building metal machines with multiple legs just to stay steady. But walking upright like us, that was the ultimate prize, and these sensors finally made it possible. Staying on our feet was really just the beginning. Next, they actually had to understand what they were looking at. Old cameras only captured flat pixels. Telling a simple coffee cup from a fuzzy moving cat is surprisingly tricky when all you see is a flat sea of color squares. Early robots were just totally lost trying to spot the difference. The breakthrough that changed absolutely everything was artificial intelligence. Instead of humans painstakingly writing out every single rule for the actual shape of a cat, we started feeding the robots massive piles of pictures. Through AI, the robots finally began to spot the patterns themselves. They learned to understand the messy world on their own terms, finally recognizing a person or a cup on a table. And miraculously, they stopped crashing into every new thing in their path. Add to that the magic of new cameras, and robots suddenly got depth vision. These new cameras shoot invisible light at a wall or an object and then measure the exact distance as that light bounces back. Suddenly, the robot is seeing a world with actual depth. It knows precisely how far away a toy is on the floor, reaches out its arm, and grabs it without missing a millimeter. It's honestly just wild to watch. Then, the tech inside our smartphones helped create these ridiculously light, strong batteries, finally giving these machines the freedom to escape the lab. And the new motors inside them act exactly like springy human muscles. If the robot moves quickly and accidentally hits wall, the motor bounces back softly. This gentle touch brought a whole new level of safety. That soft, safe touch opened up the entire universe for them. Old robots were dangerous to even stand near, but these new ones could work right beside you, gently stopping if they bumped into you. They finally left their factory cages behind. They started rolling through hospital hallways, navigating our living rooms, and even bravely driving themselves across the lonely red rocks of Mars, choosing their own safe paths incredibly far away from human help. Things got pretty extreme. Small metal robots now swim safely down into the pitch-black ocean, surviving crushing underwater pressure to film strange fish we've never even seen. Back on land, they're making microscopic, life-saving surgery cuts guided by doctors through tiny screens. Or they're zooming across giant warehouse shelves, tracking down a specific toy out of massive piles and bringing it straight to a waiting worker. We rely on so many of these specialized helpers now. Flying drones fighting the wind to deliver medicine from the sky, little vacuum robots quietly learning the layout of our living rooms and returning to their chargers. Out in the fields, self-driving tractors are planting perfectly straight rows to grow our food. And in our darkest hours, small track robots crawl bravely through the rubble of fallen buildings, hunting in the dark to rescue trapped people. But for all they do, they feel absolutely nothing. A robot only ever does what we teach it. It can't be happy and it can't be sad. It only reflects our own choices back to us. If we program them right, they show immense kindness, carrying heavy loads or holding a patient steady. But if our programming is flawed, the robot fails. It drops the fragile docks. The mistake always originates with us. We're really learning how to work together in this beautiful, strange partnership. The machine is flawless at sorting and lifting heavy things, while we humans are brilliant at dreaming and caring. We make a perfect team. But to keep that team working, we have to provide them with the right rules to keep everyone safe. We just have to look out for these machines, guiding their potential and keeping them out of trouble. Seeing them walk and talk so effortlessly really forces you to take a step back and define what it means to be us. When a machine can navigate the world, what actually makes a human special? It all comes back to our beautifully messy feelings. That's our territory. Because no matter how advanced the computer brain gets, love is simply something a robot cannot learn. A robot will never laugh in surprise because it finally understood a good joke. It can measure temperature down to the decimal, but it will never actually feel the warmth of the sun on its face. The data belongs to them, sure, but the deep, messy experience of joy, that's all ours. Looking forward, the robots of the future are going to be so wonderfully bizarre. Hard metal isn't the only way anymore. Some of them will be soft and squishy, moving exactly like jellyfish to squeeze through tiny cracks and fix things. Others will be microscopic metal swimmers, navigating through our very veins, finding sickness in our blood and fixing it from the inside to keep us perfectly healthy. The age of these machines is really just starting. We build these steel bodies and write these clever rules to reach so far beyond our own fragile limits. They're going to explore the darkest corners of the stars for us, yet they only move because we dream. Which makes you wonder, as they get smarter, where exactly is the line between man and machine going to be drawn? If you enjoyed wandering through this with me, be sure to hit like, share, and subscribe. See you next time.